Here we have the Rolle's theorem, and we want to illustrate it with this example. So Rolle's theorem says that if we have a function that is continuous on the closed interval AB and differentiable on the open interval AB, and if f of A is equal to f of B, then there is at least one number C in the open interval AB such that the derivative at C is equal to 0. And so we look at the example f of x equal to negative x to the third plus 3x, and this is what the graph looks like. And the derivative, negative x to the third, is negative 3x squared, and derivative of 3x is just 3. If we look at the interval from negative 2 to 1, so A is negative 2, B is 1, we see that the graph is continuous from A to B. And so the function is continuous on the closed interval from negative 2 to 1. And the derivative here also exists for every x in the open interval from negative 2 to 1. And therefore the function is differentiable on the open interval from negative 2 to 1. One of the conditions in Rolle's theorem is that f of A must equal to f of B. So we need to verify that f of A is equal to f of B. F of A, or A is negative 2, so f of negative 2, we just go back to this function right here. In the place of x, put negative 2. And so negative 2 here, negative 2 here. And then simplify, we get 2. So f of A, or f of negative 2, is 2. F of B or f of 1. And so go back to the function in the place of x, put 1. We get negative 1 to the third plus 3 times 1, which is 2. So f of A or f of negative 2 is 2. F of B or f of 1 is 2. And therefore f of A is equal to f of B. And so now that we have verified that f of A is equal to f of B, Rolle's theorem says that there is a number C between negative 2 and 1, such that the derivative at C is equal to 0, and we want to find that C. So let's take a look at the graph again. This is the negative 2, and this is the point negative 2, 2. This is 1, and this is the point 1, 2. The secant line connecting these 2 points is horizontal. Therefore, the slope of the secant line is 0. And to get the number C, we want to find a number C between negative 2 and 1, such that the slope of the secant, or such that the slope of the tangent line at C is equal to 0, like this tangent line right here. So we want to find a number C such that the corresponding tangent line is horizontal. And so to find that C, we'll do the following. Once again, the slope of the secant line, the slope of this secant line right here, is f of B minus f of A divided by B minus A, or 2 minus 2, which is 0, so we get 0. And then to find the number C, we look at the derivative. So the derivative is negative 3x squared plus 3. And then f prime of C, so in the place of x, we put C. Then we get negative 3c squared plus 3. And then set this equal to 0. So we set negative 3c squared plus 3 equal to 0. And then subtract 3 from both sides, we get negative 3c squared equal to negative 3. Divide both sides by negative 3, we get c squared to be 1. Take the square root both sides. Square root of c squared is c squared. And then remember that if, in solving equation, if we take the square root of both sides, we need to have a plus and minus in the middle, in the front. So we take the square root in solving quadratic equation. Remember that we need the plus and minus in the middle. So that's why in front we end up with plus and minus 1. So we have c can be 1 or negative 1. Now we look at the negative 1 first. Negative 1 is in this open interval, but when c is 1, it's not in the open interval. It's at the endpoint. And so the c we want is c equal to negative 1. And if we look back at the graph right here, negative 1, the corresponding tangent line is horizontal at negative 1. And so c is equal to negative 1.